So if the degree of the numerator is less than the degree of the denominator, there's a horizontal asymptote of y equals 0. So that would be a function that is like this, or one that is like this, where my degree of the numerator is less than the degree of the denominator. The other one that we know is if the degree of the numerator is equal to the degree of the denominator, there is a horizontal asymptote of y equals a over c, which is equivalent to the coefficients of the same degree term. So in this case, my horizontal asymptote would be at y equals 3 over 2, where I'm taking 3 from the x term on the top and 2 from the x term on the bottom. The last example that we're going to take a look at is when the degree of the numerator is 1 higher than the degree of the denominator. There is a slant or oblique asymptote on the graph. So that would be like this situation here, where I have a quadratic on the top and a linear one on the bottom. In order to find the equation of the oblique asymptote, because it is an equation, it is a line, you need to express the function as a quotient plus the remainder divided by the divisor. The quotient tells you the equation, and this part is how you determine the end behaviors around your oblique asymptote. So let's go through an example here. We're going to find the equation of the oblique asymptote and then the end behaviors. So the first thing that I want to do is I'm going to find the equation of the oblique asymptote by using long division or synthetic division. Either is fine. Let's say or synthetic. And so let's start that here. So I'm going to set up my synthetic division. I've got 1, minus 2, minus 5, and I'm going to put a 1 outside. I bring down the 1, I'm going to multiply and then add. I'm going to multiply and then add together. Now this part right here at the end, this is still my remainder. This one is my constant term, and this is my x term. So when I write my function, I can write that my function here is x minus 1 minus 6 over x minus 1. So if I change my color here, I'm going to note that this first part, this is the equation of my asymptote. This part right here, this is the leftover. So the top is my remainder, and the bottom is my divisor. So that means that the equation of my asymptote, which is what I was being asked to do, is y equals x minus 1. That is what my function is approaching as my x values get really, really large. So now the second thing that I'm going to do is to find the end behaviors, because I need to know how to graph my function. And I'm still going to start the same way. I'm going to look at what's happening as x gets really, really large, so positive infinity. And I'm going to look at as x gets really, really large in the other direction, so negative infinity. So I'm going to test the first one, x equals 100. That is a big number. And I'm going to substitute that in to this expression right here. Because the only part that I'm interested in is the leftover part. So I know that when I sub in 100, I'm going to get to 100 minus 199. I'm looking what happens to that last part. So I'm going to sub into this part right here, the leftover piece of my denominator. And I can see that if I put in 100, this is going to work out to be a negative value. So that means that I am at 100 minus 1, I'm at my asymptote, and then I am taking away a little bit. So that means that I'm approaching my asymptote. So I'm going to say that I approach my asymptote from below because this value is negative. So now I'm going to see what happens as it gets large in the negative direction. So I'm going to test x equals minus 100. Same thing, I'm substituting into this leftover piece after I do long division. And I'm going to sub in, so I've got minus 6 over minus 100 this time, minus 1, which is going to equal a positive value, which means that I'm going to, when I'm at x equals minus 100, I'm going to get to x minus 1. I'm going to approach my asymptote, and then I'm going to add a little bit to it. So my value is going to be above. So then I say that I approach my asymptote from above because this is positive.